opening and introduction. Good day, everyone. I'd like to thank you all to take your time to join this webinar. My name is Craig Zhang from Shanghai SGS. So today, my topic is root cause analysis for chemicals in wastewater. So in today's webinar, we divided into my presentation divided into 5 sections. First, I'll introduce the detox and the ZDC wastewater guidelines. Then I'll introduce the 2020 wastewater data analysis and frequently filled items. Then the next is the root cause analysis service. As the next section, I'll share some root cause analysis case. And then at the last, I'll introduce SGS wastewater testing and related service. And at the end of my presentation, we have a Q&A section. If you have any questions, you can type your question in the board, and I'll answer it online. So let's begin. First, I'll introduce the detox and the ZDC wastewater guidelines. So, as we know, the textile footwear industry have long been regarded as one of the most economically harmful industries in the world. This is due to the large number of chemicals and the large amount of water used and discharged into waterways. So you can see the slide. The diagram show an example for wet processing. At the beginning, the raw materials such as cotton need to be pre-treated. And in this step, we may use sizing agent, sourcing agent, etc. This agent may containing the harmful chemicals like heavy metals, APU, etc. Then at the next step, is the printing and the dyeing process. In this step, we usually use a virus of dye stuff, of course, and also with some dyeing promoters. And they may contain azo dyes, organotin, etc. The last step is the washing and the finishing. In this step, many auxiliaries will be used in this step, and they will bring the risk of formaldehyde, PFC, and many other restricted substance risk. So here I can give you some numbers for you to understand why we need to take some actions to solve this problem. The modern textile industry is a typical chemical processing industry. For example, the European textile industry is based on about 15,000 complex chemical formulations, and around 9.3 million tons per year of chemicals were used in global textile production, and nearly a quarter of the chemicals produced worldwide are used directly or indirectly for textiles. So let's see the next. The detox, why we need to start the detox campaign. The chemicals discharged from the manufacturing sites pose a global environmental concern, and the famous NGO Greenpeace released a report, The Dirty Laundry, on July 12, 2011, which revealed the hidden relationship between the textile manufacturing enterprises discharging the hazardous substances into water and international brands. So the NGO Greenpeace launched this detox campaign on the next day, and leading the brand's zero discharge commitment. And this detox campaign has been spotlighted with continuously publishing further reports to monitoring the progress. And then this is the stories begin. After the detox campaign, the textile industry is facing the challenges from the public, and would like to clean up the supply chain. And then another NGO, ZDC, the full name is Zero Discharge of Hazardous Chemicals, was formed by 6 famous brands. And CDC was formed at the end of 2011, and its vision is the widespread implementation of sustainable chemistry, driving the innovation and best practice in textile, apparel, leather, and footwear industry to protect consumers, workers, and also as well as the environment. And CDC identifies some key focus area for input, process, and output to provide information, provide tools, training, and also some important technical documents, guidance to assist the brands and their suppliers on implementation. So let's see the key focus area. There are 3: input, process, and output. In input area, the CDC launched the MRSL, very important technical document in this industry, and also a document called MRSL Conformance Guidance. It has helped the chemical supplier to identify to verify their chemicals without any hazardous chemicals. All their hazardous chemicals are under the list. And in the process area, the CDC also released many documents or tools or guidance like chemical management system framework or performance in-check guidance, etc. And in the output area, the CDC released their wastewater guidance for the suppliers, and also released wastewater and sludge laboratory sampling and analysis plan. And besides these documents, the CDC also provide website platform for the brands and the suppliers, and they call it ZDC Gateway. So in input area and output area, the chemical suppliers and the suppliers of the brands can upload their chemical data or wastewater testing data onto this platform, onto ZDC Gateway. So in ZDC Gateway, they have a chemical module and a wastewater module. So let's coming to today's topic, key words, wastewater. So the ZDC wastewater guidance, this is to eliminate the use of hazardous chemicals in the production of textiles, leather, apparel, and footwear. And wastewater testing is an important way to identify the source of problems and test the results of detox campaign. CDC issues the CDC wastewater guideline version 1.0 in November 2016, which was updated to 1.1 in July 2019. And these guidelines are the recommended requirements of CDC for supply chain factories. Each factory should meet these requirements of local regulation and standards, as well as this wastewater guidance. In this guidance, they have 3 parts. One is conventional parameters, and the second is ZDC MRSL parameters, The last is sludge parameters. So let's see these three parts one by one. For the first is a conventional parameter. In this parameter, they have two tables. One is for some parameters or usually tested for the wastewater, and also required by many government monitoring requirements like COD, BOD, total PAOX, etc. And in another table 1B, this table is required and provide the requirements on heavy metals like SB, PB, lead, etc. So this is a conventional parameter. And in the next part is the MRSL parameter. In this parameter, we can see many familiar restricted substance in MRSL like APEO, azodide, flame retardants, organotin, PFC, VOC, and there are 16 groups of restricted substance for the wastewater to test. And the last is for the sludge. The sludge parameter is very close to the wastewater, and they add some heavy metal requirements, and also with many groups of restricted substance in this table. So this all the three parts is the requirements in DDC wastewater guidelines. Next, let's see the wastewater data analysis in 2020, and we can also share. I can also share some frequently filled items in this section. In statistical wastewater testing results of SGS Shanghai Laboratory in 2020, 13 restricted substance categories failed in these test items. Among the 3 restricted substance categories, the failed items accounting for more than 5% were heavy metals, organotin compounds, PFCs, APEO, halogenated solvents, phthalates, and azodides. And the top one is heavy metal, then is organotin compounds. You can see their percentage in the slide. And we also list the field items in these categories, and we list the top 10 field items in this table. And if you want, and also we also list their potential uses in our industries. So if the factories failed their wastewater testing and the field item is listed in this table, you can read this. You can see the potential use and find and try to find maybe the causes are listed in this potential uses. Okay, let's see the root cause analysis service. The root cause analysis, we usually use the short name RCA. The RCA is to highlight the high-risk restricted substances within manufacturing processing. And it concerns the production line review and audit and training on chemical management. And it is order to validate the chemical input and to identify the root cause, and also to propose an action plan for the factory to improve their chemical management. And also, the RCA can help the factories raise their knowledge and awareness on chemical management, input chemicals, inability in risk identification, and also on the chemical inventory. And also, RCA can help factories understand the root causes of chemicals tested in their wastewater or also in their production. So in this diagram, you can see the RCA from failure rates analysis. If you got some failed tested results, and you need to identify the risky restricted substance parameter and to identify the risky suppliers, also identify the risky materials and the products. And then you may conduct the root cause analysis. And after this RCA, you can take some actions to solve the problem, to maybe replace your high risky chemicals, and then form a circle, a positive circle. It is a continuous improvement. And this way we can show how to conduct a root cause analysis. A root cause analysis usually divided into two parts. One is in the chemical inventory, and another is on the chemical management system and technical gap. So if you found some failure in the wastewater testing, they may come from the inventory chemicals, like maybe in dye stuff, maybe in the auxiliaries, or also maybe in some wastewater treatment processing or some contamination. And all these causes may lead by the chemical gap, the technical gap, or the lack of knowledge in chemical management. So in the root cause analysis, we will help the factory to improve their knowledge and awareness on some technical points like chemical inventory, traceability, GHS, NSDS, storage and handling, MRSL implementation, and also on chemical risk identification. So this is a very simple diagram to show how to conduct a root cause analysis. First, we need to find some. We have to find some high risky or risky chemicals or root causes in their chemical inventory, and they must be caused by their technical gap. And first, we will review their wastewater report and do the analysis. Then we will review the chemical inventory and SDS. And then we will go on site to investigate and to review their chemical performance on site, and also maybe interview their employees on site to find the real reason for the test failure. And at last, we will sample on site sample the high risky chemicals on site and do the testing. And for the testing, if the suppliers would not test their chemicals in this case, the sampling and testing is optional in RCA. And this is the workflow for the root cause analysis. There are three stages: pre-waste, on-site waste, and post-waste. In pre-waste, we will first conduct the project kickoff meeting, organize this meeting to discuss with the client, with the factory directly, and then we will connect their technical documents, including the SDS, the DOC, the test reports, the certificates, etc. Then we will review these documents to find maybe some chemicals have a high risk on some category of restricted substances. Then we will visit on site. First, in the waste on site, or maybe we can call it a kind of audit. First, we will visit their production line, and also we will, as I mentioned before, we will interview their employees, and also to investigate many points or many parts not from the production. Maybe this part may also have some reasons to cause failure in their wastewater testing. And also in the on-site audit or on-site visit, we can do the sampling. And at the end of the on-site visit, we will give some guiding or conduct some training, or give some training to the factories to raise their awareness of chemical management. And after the on-site visit, we will go back to the office and first test the sampled chemicals, and to finish after we receive the testing results, we will complete the report and give the report to the factory or maybe the brands. This is the whole workflow for RCA. So this is an example for on-site agenda. So on day one, first we start with an opening meeting to introduce the RCA and also to introduce both teams in this project. And we can also arrange the visit for the 2 days. Then we will check the general information and the production line, and also and to discuss the field cases with factory teams. And next we will start our factory tours. The tour including the chemical or raw material warehouse, and also the production line, also manufacturing process, the waste storage, and wastewater treatment plants. And after the factory tour, we will also do some document review and discuss and do some summary for the day one tour. And at the next day, we will finalize the sampling plan and do the sampling. The sampling can be done on chemicals, raw materials, and finished products if we found some risk in chemicals or materials. And also we will discuss with factory teams about their failure. And also in this time we will give some guiding to them, or maybe some short training. And at last we will start the close meeting to give the factory team the summary of the RCA and go back to office to finish the testing and project report. So this is the RCA feedback loop. The RCA should be conducted in process and input to determine all possible scenarios leading to the failures, and also the RCA need to close the feedback loop to help the factory to avoid the future occurrences. So maybe in this diagram I give some example, like if the factory finds some failure in their wastewater testing. The field item is APU, and the results is 3,000 ppm, and then they need to conduct the root cause analysis, the RCA. First, they go back to they check the root cause back to the washing process, and maybe need to check the chemical used in washing may contain APU or not, or the chemicals may whether the chemicals used correctly or incorrectly. Then go back to the dyeing process and also check the chemicals in this process, contain APU or not, and used correctly or not. Then go back to the roots, go back to the inventory. We need to investigate the inventory chemicals, check all the chemicals. And in this case, maybe we will find that the washing auxiliaries contain APU. Then we will need to close the feedback loop. First, we need to take some action to solve the problem. We need to seek for the alternative washing auxiliary. Then the factory also need to train their workers to ensure the workers are aware of this case and also prevent the future failure. And this is the feedback loop in RCA. Okay, I introduced the RCA and how to conduct RCA. Next, I will share some RCA cases. The first case, in last year, a certain factory of brand A tested in their wastewater in March and May, and a total of 8 groups of restricted substance were detected, like APU, PAH, VOC, etc. As commissioned by brand A, SGS is a request to conduct a root cause analysis on this factory. And in these cases, we take some actions like review their CIL, discuss and interview factory management, and also review their ingredient in their chemical SDS, and also review all the available SDS whether based on the GHS requirements or not. And we have some findings. First is not all the chemicals have a corresponding information like DOC test reports, and on-site in the on-site visit we classify all their chemicals in 3 risk categories: high, medium, low. And based on the review of the ingredient in the SDS, 6 chemicals were found to have the restricted substance risk. We give some 2 examples in the words, and also some other findings like in this factory, the washing process in the workshop is one source of wastewater, and but most cleaning engines don't have any test reports or some verification, to verify these engines don't contain any RS in the ingredients. And also this factory also have a washing laboratory, and they do lots of washing tests, and this may be another source for the field item, for the field restricted substance in their tests. And for the CIL, for the chemical inventory list, only 2.9% of chemicals in CIL have a test report, and also the test report don't contain all the MRSL test items, test parameters. So this may be some root cause for their field items, for their wastewater test failing. Another cases for the RCA, Factory B conducted the wastewater in November 2020 and found several groups of RS, and to improve their chemical management performance, our team conduct RCA for them. We gave the table for their field items. In this case, we also do some actions on site, and I just talk our findings directly. First is we found chemicals have NPEO in their ingredient after review its SDS, and another is that the factory submit their SBIL, the chemical inventory list, and this list don't contain many important information like SDS, DOC, or the certificate test report, and only contain the name, the supplier name, and the unit and the consumption, and just this information is not enough for the root cause analysis. And also we found that they don't have any DOC for their used chemicals, and also found
it looks like we have a small technical issue with the presenter, so I think we have to wait maybe a few seconds so that he can call in back. I think he lost the connection. In the meantime, maybe I can just remind or inform you that at the end of the presentation, we will display a short satisfaction survey so that you can share with us your comments. So it will help us to improve and offer you relevant and quality content information.
Hi, Valerie.
Yeah, you're back. Okay.
Sorry, I just dropped my line. Sorry, another time. Sorry.
Okay, you're back. Thank you.
Yeah, I can continue in this slide.
Yeah.
And for the case 2, for the RCA, another cases, we also found many other findings, like the water repellent. This factory used many raw materials like water repellent fabric, and this fabric will after the washing process may release the PFC in the wastewater, and this is another finding. And also concerning the AS and PB were detected in the sludge. The enrichment effect of the sludge should be concerned. Maybe this is the cause for the heavy metals. And for the DEHP in the sludge, maybe it is because the result is not too far beyond the reporting limits. So the sludge, the enrichment effect of the sludge may also another important factor for the DHP, for the phthalates. So this may be another causes for the RS. And the factory, after the RC, the factory need to communicate with their chemical suppliers and also the raw material suppliers to ensure their chemicals the used chemicals and use the raw materials, use the RS3, the RS3 chemicals in their inventory chemicals. Okay, so the last section I'll introduce SGS wastewater testing and related services. This is the wastewater sampling diagram. There are 4 sampling points, 3 for water and 1 for sludge. The 3 water is incoming water, raw wastewater, and discharged wastewater. For the raw wastewater and discharged wastewater, one is before the wastewater treatment, and another is after wastewater treatment. For the wastewater testing frequency, based on the ZDC wastewater guidelines, the test frequency is twice per year, and one is no later than April 30th, and another should be before the October 31st of each year. And these two, the two testing, the time interval between these two testing, the two sampling should be no less than 3 months. So, for example, if you conduct the first wastewater testing in April, you cannot conduct the other wastewater testing in May or in June, because the time interval should be more than 3 months. And the DDC wastewater testing can only be carried out by a DDC accepted laboratory, and the laboratory can help the suppliers to upload the wastewater result report to the platform, like IPE platform for the detox or the DDC gateway. And for the sampling, the composite sampling should be performed for no less than 6 hours, and without more than 1 hour between the samples. And the sample should be taken by a qualified laboratory. And SGS is also a ZDC accepted laboratory, and the sample should be taken under the normal production scale of the factory, and no sample can be taken during the time when the production process is not running, or the wastewater is diluted due to for example, the heavy rainfall. And maybe last year we all met the COVID-19 pandemic, and many factories cannot hold their normal production scales, and in this time we cannot carry out the wastewater testing, the wastewater sampling. And this, you can see some pictures for our wastewater sampling, and the different test method require different sample collection containers and a storage method, and all the steps, including the sampling, the testing, and the disposal, are controlled by keeping monitoring records. And SGS laboratory also must keep this record when the employee do the sampling, and it takes 10 working days for receiving the samples to issue the test reports. And besides the wastewater testing and RCA, we also have many other services for the chemical management. We have a one-stop. We call it a one-stop services: on-site sampling, testing, data management and analysis, holistic solution, and also we can support the supplier and brand to provide the consultancy and the research.